what do the observations tell us about this region here? Now, with ground-based telescopes before the Hubble, we could only see back into time only so far, just because the objects get too faint. But Hubble has enabled us to peer deeper into the cosmos in the past. And in order to investigate this and try to give observational confirmation of these theoretical predictions, a group of us at the Institute, as soon as the spherical aberration of Hubble telescope was corrected, made the decision to try to point the Hubble out in space, looking between the stars in our galaxy to actually see if we could image out there and try to capture what galaxies at great distances look like. So I gathered together, I was director of the Institute at that time and had access to the telescope, because part of our contract with NASA is that the director of the Institute gets 10% of the telescope time to do as he or she chooses. And I thought with some young scientists at our Institute that it would really be worth taking the telescope for a long period of time and trying to see if we could detect very distant galaxies. So this was a risky project because there was no guarantee that we would have any success. In fact, there had been several studies undertaken by well-known astronomers that indicated that Hubble probably would not, even though it could do better than ground-based telescope, was not likely to be able to reveal very much about the evolution of the universe more than 4 or 5 billion years back, although that still would have been progress. So, and there was several other factors that were relevant. And one of them was, with no guarantee of success, with astronomers around the world dying to get time of the telescope, what would the reaction be if we ended up with really no detection of distant galaxies? Taking the telescope, it turns out, for 10 days, which is what we decided to expose for, right after the servicing mission to correct the spherical aberration had cost $1 billion. Director making a crazy decision like this, there was a lot of pressure basically within the community for us not to do this. But a group of us felt that given the fact that Hubble was a premier instrument, we had to try it. So the fact is, we did commandeer the telescope for 10 days, taking exposure after exposure, electronically adding them all up. And we imaged what we called the Hubble Deep Field. It was a blank area of sky where we knew from earlier observations, Palomar Sky Survey, that we would see at least 50 to 100 galaxies. But the fact is, what Hubble revealed after 10 days of exposure was 3,000 galaxies, some of them relatively nearby and therefore brighter and larger. So here's a relatively nearby galaxy. By the way, its distance is 1 billion light years. There are others here. Here's a spiral galaxy. Down here is a spiral galaxy. And all the rest of these objects, there are just a few stars here. There's one, and there's one. But everything else that you see in this image are galaxies. Some as close as 1 billion light years. The most distant, it turns out, at 12 billion light years. The fact is, we were very fortunate in being successful and essentially in this image, this core image basically, where we're looking back in time, able to reveal the existence of galaxies and determine exactly what their morphology was like. So we could say, this is how structure in the universe has changed from a few billion years after the Big Bang to the present time.